Hi as well. Last but not least, lesson 7 then, vectors and scalars. So you should be pretty happy with your trig identities. Equally, I really think that you shouldn't have found task 1 very difficult. So scalars obviously have a magnitude, vectors have a direction along with that. So just check that you got those right, pause the video if you need to. Change any, ask me questions if you've got any, but you should have been okay with that. So question 2 asks you to draw a scale diagram and then mathematically prove the resultant in this case. So you've got a swimmer crossing a river, swimming due north at 2 meters per second. So I did a scale of 1 centimetre for every 1 meter per second. So I've got a 2 centimetre northbound vector. The current, which is also going to be pushing the swimmer, so both the force due to muscle exertion and the force due to current flow are acting on the swimmer 5 centimetres east. So in this case I've got tail to tail, so I need to do the parallelogram method. So I draw construction lines parallel to each vector at the ends, and where they cross, that's where my resultant ends up. I measured this line and it was 5.4 centimetres, so therefore my resultant must be 5.4 metres per second. I really want to see nice clear diagrams, please. So with Pythagoras we can say that 5 squared plus 2 squared must equal my hypotenuse squared. So I've got 25 plus 4. The square root of that must equal the resultant. The square root of 29 is 5.385, and obviously that rounds to 5.4, so I'm proving that my scale diagram must have been good. Sorry for the noises in the background. Question 2 then, we've got vector x, or vx, pointing northeast, and we've got vy pointing northwest. Minus Vy is literally just the same magnitude, so the same length arrow, but now pointing in the opposite direction. And so now I have vector minus Vy. And so Vx minus Vy is the same as Vx plus minus Vy. So I'm just adding these two vectors together. So I've got Vx, as we can see, minus Vy is opposite to Vy, so I've got Vy minus Vy pointing down. I've got top to tail, so I'm just going to close my triangle here, and so my resultant is directly across, and you can hopefully see that this is in the same direction as D, so that gives you D. And then in question 3, a river is flowing north. A boat crosses the river so that it only moves in the direction east of its starting point. So east is obviously over here. There is a force due to the river flow acting up. And so if I'm the boat and I'm here, and without any steering at all, the river pushes me north because it's flowing north, I know that I have to provide steering in this direction, so providing a force down this way, so that my resultant points due east. Okay, because remember, if I've got a force acting up plus a force acting southeast, I'm going to end up east. So then you look for the vector that is running parallel, and so that's C. So then question 4 was a quiz online. I'm just going to take a photo of these answers, I think, because they're pretty straightforward. It's just a lot of Pythagoras, so I'm not going to spend a whole lot of time going through those, but they will be there, and I'll add a link in the notes of this video to that for you. And then in task 3, you were asked to resolve some components of vectors. So we've got a ramp, we've got a box acting on the ramp. Obviously mass always acts towards the centre of Earth, so it will always act vertically down. So this is acceleration due to gravity. Okay, and so without the ramp, if this were just in free space, it would accelerate down due to gravity. But obviously that's not the reality of this situation. You've got some friction on the ramp, you've got a normal reaction force, so the ramp pushes up on the box. Don't worry about any of that for now, we aren't on the forces topic yet. But just at its most basic, if we've got acceleration due to gravity down, and we call that G, and we know the angle to the horizontal is 37, so that's this angle here, we can use rules of triangles to prove that this angle must equal this angle. Okay, now think about it carefully. I can sketch out a triangle here, and there is a right angle there. I want you to imagine picking that triangle up off the page, rotating it round until it fits in, and flip it over. So we've got our right angle here now. Okay, so I want you to pick up these two pieces, and basically I want you to flip the triangle over. Okay, so because of rules of triangles, I know that these two angles are the same. I'm pretty sure that maths are going to go over triangle angles with you anyway at some point. But if this is something that you're not confident with, can you send me a message now so that I know that you might need a little bit of extra support with that? Okay, so we agree that we've got an angle here. We know we have our original vector acting down. The acceleration down the ramp is this one. Now remember from my previous video, we are sweeping away from the angle that we know, so therefore this is going to be the vector sine of the angle, and then obviously at 90 degrees to that we have through the angle, and that's cos. We want this value. G is just 9.81 and we're told the angle was 37, so you're just subbing it in there and you get 5.9 meters per second squared. Similar situation, the helicopter, when it is flying, lift, so the force acting up against the rotor blades, will always act at right angles to the blades. Okay, that's just a fact. Lift will always act at right angles to the blades. So if the vertical is 15 degrees around from the lift force, we can work out the component, because remember we've got the vector of 250,000 newtons. We sweep through an angle of 15, the vertical component of that must be L cos 15. We're sweeping through the angle. And then again it's sine 15 for the horizontal component, just like I showed you on the video before. Okay, so pretty straightforward. Now this next one, drawing a scale vector diagram and checking and comparing with trigonometry. So we've got some details that we need. We know vector A as value, we know the value of vector B, and we know some angles here. We're trying to find R. So first things first, a scale diagram. I went with 1 centimetre representing every metre. Now I was told that vector A was 53 metres, so I drew a line that was 5.3 centimetres long. I used my protractor, and this is at 20 degrees. It really matters that you get these angles correct. Okay, so please, please, please make sure that you're getting a protractor from my desk if you don't have one. At the end point of this vector, I then drew a new horizontal line so that I could measure my next angle, which was 63 degrees. 34 metres represented by 3.4 centimetres. I've got, so my vector is pointing up this way and it's pointing up this way, so I've got a top and a tail meeting. Therefore I close my triangle to find the resultant. I measured this, it was 8.2 centimetres, therefore using my scale I have 82 metres. Now what you can do, bearing in mind, let me just grab some different coloured pens, that this is vector A and this one was vector B. Okay, what we essentially do to use trigonometry is we say, okay, well let's split this into its horizontal and its vertical component, and let's do the same for vector B. Okay, what I'm essentially saying, sorry, it's not a very good line, is that in total, horizontally, I have this much plus this much, and vertically I have this much plus this much. Okay, now that's what I've done down here. So my horizontal component of vector A was my 53 cos 20, because I'm sweeping through that angle, plus 34 cos 63. Okay, I'm not using 5.4 and 3.4 anymore because I need it to be the true value, because I'm just using number crunching. Okay, so in total horizontally, I know I've got this, and I plug that into a calculation, I get 65.2. Vertically, it's going to work the same. I've got my vector A, 53. I'm moving away from the angle of 20, so therefore it's sine. So I've got 53 sine 20, plus I have 34 sine 63. That makes 48.4. Now what I have, basically, is a right-angled triangle. I've got a 65.2 horizontally plus a 48.4 vertically. To close that triangle, my resultant is going to be this line, which hopefully you can see is the same as this one. So I'm going to just say that 65.2 squared plus 48.4 squared is r squared, just from Pythagoras. And when I sub that all in to my calculator and rearrange for r, I get 81.2 meters. So when I do it with no scale diagram and just use the numbers that I'm given, I get 81.2 meters. This is likely to be much more accurate than my scale drawing, bearing in mind that I've done this by eye. You know, it's with a bit of a wonky protractor. It's not going to be perfect, but these two numbers are very close together, and so I know that my scale diagram is not bad. So it just shows you that there are two methods that you can use, and you'll get the same answer. So hopefully that helps break down vectors a little bit more for you as well.